This is our lesson on introducing you to radian measure, and we're going to start the lesson with a YouTube clip from someone who explains very well what a radian is.
In the previous video, we looked at how angles are measured using degrees. This angle would measure around 30 degrees, a right angle would measure 90 degrees, a straight line 180 degrees, and one complete rotation 360 degrees. Do you know why 360 degrees? It's somewhat arbitrary and has something to do with the base 60 number system. Do we have some other way in which we can measure angles such
as... Short interruption, try again.
Radians mean? Most people know how to convert from degrees to radians and vice versa, but it ends there. To understand what radians mean, let's draw a circle. Let point O be its center and length R be its radius. Now let me take this length R and place it here at this point. Now all I do is push it onto the circumference of the circle. The length of this red part is still R, it has just become curved and that's all. The curved length R starts from here and ends here. Now from the center of the circle, we draw another radius that joins the other end point of the red curve. This length will also be R as it's the radius. Let's analyze the figure. We have an arc of length equal to the radius of the circle and two radii joining the center and the endpoints of that arc.
I want to stop there for a moment. So we're still recording, by the way, but we stopped the YouTube video. That shape there with R, and R, anyone have a name for that shape? Yeah, a pizza slice. Yeah, it looks like a pizza slice. It does have a name. Now, some kids are like, oh, it kind of looks like a triangle, and you're right. It does slightly resemble a triangle, but it's got that arced edge. It's called a sector, is the official math name for it. But if we could pretend like it was a triangle for a minute, does anyone have any thoughts as to how big this angle would be? As far as, like, estimating it. Go ahead, shout them out at me. 45. I've heard 30, 40, 45. 30. Lots of 30s going out there. Huh. 50. Lots of 45s. Feeling it? All right. So, guys, if we pretend this is a triangle for a minute, is there a special triangle out there that has all the same sides? Equilateral triangles. Do you remember anything about equilateral triangles? They have equal angulars as well. Yes. So if all the angles are equal in a triangle, they're 60 degrees. So do you think it's going to be too far off from 60 degrees, whatever that mystery angle is? I guess we'll find out. All right, go ahead, lady.
Remember, the length of the arc is equal to the radius of the circle. This angle formed here is 1 radian. That's the concept of radians. Actually, there's radius everywhere around this angle. R, and that's probably why they call it radians. According to various scientists and mathematicians, this is a more logical way to measure angles. It's because we are measuring the angle in relation to the radius of the circle. But how are radians related to degrees? What would this angle be equal to in degrees? If you understood the concept of radians well, then understanding the conversion between degrees and radians would be a walk in the park. What is the circumference of a circle? It's 2 pi r, where r is the radius of the circle. We are talking about the circumference, which is the entire boundary of the circle. Now listen to the next question well. How many such arcs would you need to cover the entire boundary of the circle? Let me repeat the question. How many such arcs of length r would you need to cover the circumference of the circle?
So let's answer her question. What do you think? How many of those red R's would it take to get all the way around the circle? I heard 6. Any reason other than just a visual estimation? Just feeling like it's 6. Visualizing 6 of them? Okay. You're really close to the right answer. I haven't actually heard the right answer yet.
7.
7's not right.
4.
Getting colder. Getting colder.
9. 8.
So I'm going to put a stop to this game, guys. She's going to explain what it is.
Pause the video and see if you can work through this on your own.
Man, every time. All right, so we already did that. So your guess was 6.
1.
The length of the arc is r, and the circumference is 2 pi r. Yes, 2 pi r. it means we would need 2 pi such arcs to cover the circumference. 2 pi arcs? What does that mean? As pi is approximately 3.14, we would need 6.28 arcs to cover the circumference.
So your guess of 6 was
How would
close.
it look? This is 1 arc, 2, 3, 4, 5, 6, and a little part left for 0.28 arc, or 28% of an arc. So we need 2 pi arcs to cover the entire circumference. And what does each arc correspond to at the center? We have seen that 1 arc corresponds to 1 radian at the center. It implies that to complete 1 full rotation, we would need 2 pi radians. And it tells us something more too. If we rotate 1 arm completely, then 2 pi radians will be covered at the center. But wait, hold on. We also know that 1 full rotation equals 360 degrees. Yes, 1 full rotation equals 360 degrees. As both equal 1 full rotation, these two will be equal. 2 pi radians will equal 360 degrees. That's the relation between degrees and radians.
All right, so that's one of my favorite little math tutors. She does a nice job of simplifying really complex stuff. That's the conversion that we're going to use today on our lesson. So in your notes packet, we are going to jump down to where you see, they explained radian on your notes packet as well, but find number 10. It's right underneath a little box of notes, and it says you can convert between radians and degrees because on your notes it shows you that if 2 pi radians is the same thing as 360 degrees, well, look what happens when you divide. This is a new notes packet, just on the front of it, okay? If you divide both sides by 2, well, then you're left with pi radians is the same thing as 180 degrees. So in science class, you do this a lot with dimensional analysis, where you're given some conversion factor and you have to like convert feet to miles and, you know, inches to yards, and you have to multiply by the conversion factor. Well, same thing in math. It's really a math problem if you think about it. So here it says how you convert. They give you little formulas up here. Well, these are all degree measures in the top row, and we're going to convert these to radians by simply multiplying by pi radians over 180 degrees. Now, I'm going to leave the labels totally off of my work. I'm just going to put the pi over 180 part. So on your paper, please multiply 18 by the fraction pi divided by 180. And I don't want you to do any math yet. I just want you to kind of push this fraction together. So this ends up being 18 pi divided by 180. This is almost a great answer. I just need you to simplify it a little bit. So I need you to simplify your coefficients. Don't worry about the pi. What is 18 divided by 180 if you simplified it? Math enter, back to a fraction, please. I heard 1/10. So this is 1 pi over 10, or we can just say pi over 10. So 18 degrees is the same as pi over 10 radians. That's us converting. Okay, number 11, we're going to multiply, same thing. We're going to multiply by pi over 180. And then I'm just going to push it together as one fraction and write 6 pi over 180. But that's not a reduced fraction. So without the pi, just the 6 over 180, I need you to reduce that fraction coefficient, please. And it's 1 over 30. So 1 pi over 30, also known as pi over 30. Very good. So 6 degrees is the same thing as pi over 30 radians. So what if the angle's negative? You think that changes it? No. Not at all. So you still multiply by pi over 180. So now we're looking at negative 72 pi over 180. I'm just going to use my calculator, and I'm going to math enter that fraction so it reduces. I need a little help with that one. Someone help me out with that. One more time. Negative 2 over 5. So negative 2 pi over 5. So that's how many radians is the same thing as negative 72 degrees. And then negative 820, I'm going to run out of room, but you're going to multiply this by pi over 180 like we did on all the other questions. So on your calculator, I'm going to need you to reduce the fraction of negative 820 over 180. Negative 41 over 9, thank you. I ran out of room totally, huh? So negative 41 pi over 9, you said?
Yeah.
Okay. Gosh, can't even read that. Guys, that says negative 41 pi over 9. All right, so what if we have the opposite? what if I give you radians and I would rather have degree measure? So when that happens, you just take your conversion factor and you flip it. So instead of pi over 180, we're going to multiply by 180 over pi. So guys, can you take a real careful look at that fraction that we have here? We have 4 pi over 1 times 180 over pi. Does anything cancel? Pi's, yeah. So the whole point of this is to get rid of the radian measure, which is the pi thing. So pi's gone. And now you just have to type in question. 4 times 180, you're not dividing by anything other than 1, so it's just 4 times 180. 720 degrees. Very good. All right, same technique here on the next problem. You have 5 pi over 2, and you're multiplying by flipping the fraction 180 over pi. So again, the pi's are going to cancel. And on your calculator, you're going to type 5 times 180, but you're dividing by 2 because it's in the denominator. And I heard 450. Thank you. So what if it's a negative radian? Is it different? Not at all. So you still multiply by 180 over pi. Pi's are going to cancel. That's how you know you're on the right track. And then everything else you type in your calculator. So negative 9 times 180. And you also have to divide by 2. Negative 810. All right, one more. And then that's our whole lesson, believe it or not. All right, so negative 7 pi over 12. You're going to hit that by 180 over pi. Again, pi's are going to cancel. Negative 105, good, because it's negative 7 times 180. You're dividing by 12, and I'm hearing it's negative 105 degrees. Very good. Someone in the last class asked me if I forgot to put the degree symbol, are you going to mark me down to a 4 or something? I said no, but what I do not want to see is if the answer is supposed to be degrees and you label it as radians, or like you left the pi in your answer, that would be wrong. So be very careful about that. All right, quickest lesson ever.